Hello, students. So we're going to answer a couple of questions at once. So here are some of them. What happens if we try to make a tuple comprehension? What happens then? Here's another one. What happens if we use a function like sum or list, but we don't put any brackets at all? No brackets, bracket free, going wild, just tossing off the brackets. Let's see what happens. So let's think of a situation first. Suppose we wanted, uh, let's say the sum of the numbers from 1 to 100 inclusive that are not divisible by 3. Okay, so we understand what we want. We could compute this mathematically. If we have the formula from Calc 1 and other classes that allows us to add the first n integers, we could add 1 through 100, and then we could separately figure out what the sum of the numbers that are divisible by 3 are, and we could subtract that off. And it's not hard to find out the sum of the numbers that are divisible by 3 because they're all multiples of 3, so we could pull a 3 out, and we could use the same formula again. That's great. Fun exercise. We're not going to do it because we want to do this using Python. Okay, so how could I do this? Well, let's make a list of the numbers that are not divisible by 3. So I in range 1 to, I want inclusive, so 1 to 101. I only want it to count if it's not divisible by 3. So if I mod 3 is not equal to 0. And I get these numbers here, 1, 2. You can see I'm skipping the numbers that are divisible by 3, no 6, no 9, no 12. So this seems to be working. I could also do this a little differently. What happens if I just did this? That would work as well. Because what's happening here? Well, remember 0 is false. Anything else is true. So if I mod 3 is 1 or 2, it's going to return true. So it's going to include the number. And those are the numbers we want, the ones that are not congruent to 0. Okay, but this is not what we want. We want the sum of this thing. So let's put this in sum and see what happens. So I'm putting this in sum, and I get a nice little answer. Okay, but I don't really care about that answer to begin with. I made this example to answer the following question. What happens if we take off the brackets? Don't be afraid to experiment. Computer's not going to blow up because we took the brackets out. Might give us an error. What kind of an error is it going to give us? Well, let's see. Oh my, look, it ran and it gave us the right answer. So what's going on here? Well, let's try something else. So we had two questions. The other question is, what happens if we try to create a tuple comprehension? Okay, let's see. Let's take this in fact, right? Parentheses like in a tuple, right? I might expect this to create a tuple comprehension. Now, I've already said tuples, they're not elastic. We don't have a slinky or an accordion here, right? Tuples are very fixed, immutable things. Let's try to see what happens here. Interesting. I get an object. Well, everything in Python is an object. What kind of object? It's telling me I have a generator object, and it's telling me where it's stored in memory, not that I necessarily need to know that. Now, this is a strange thing. So what do we do with strange things? Hey, we see what type of thing it is. Now, it just told us, but it'll tell us again. And boom, it's a generator. Now, generator is a great name. A generator is something that will generate things. It's a generator, something that will generate things. It is not a generated. It did not generate the things, but it's ready to generate the things. So basically, you could think about it as a promise in memory, right? That it'll generate those things when needed, but it won't generate them unless they're needed. So if I wanted to force that need, I could say, hey, give me these things right now. So let's do that. Let's say, list the things in this generator. List them. I need them immediately. And what do I get? I got the same things, right? I got this was the collection. So I can force them out. But what we had here is we had a generator. That's something that is a promise or a method for getting the things that we want, but it doesn't store them all at once. This is something that's called lazy evaluation. And I know lazy has all sorts of negative connotations to it, right, as a word. But lazy isn't necessarily a bad thing in programming, actually, in any way. I mean, lazy evaluation just means that we're going to wait. We're not going to do things till we have to, right? So this is an example of lazy evaluation. If I just ask for this, it, okay, sets aside a rule for creating it. And unless I need it, it doesn't do it. So kind of lazy, right? That could be considered lazy. I mean, there's another lazy in programming, which is you're too lazy to do something by hand with the methods that you're given, so you come up with a really clever trick for doing it. And that's another type of lazy in programming. That's a good type of lazy. So lazy can be a good thing. Um, but basically, we have these things. They are generators. They do not store everything in memory. Now, why might this be a great thing? This might be a great thing because in math, we deal with lots of very big things. I've dealt with matrices that have thousands and thousands of rows and columns in Python. And I've dealt with permutations, and those get big very, very fast. I mean, 12 factorial is already huge, never mind 20. So if you're taking things from like a very large collection, and the computer doesn't need to store everything in its memory at the same time, then you don't want it to store everything in the memory at the same time. An example of something that we've already known from the very beginning, well, maybe not from the very beginning, but from very early on, is range. If I ask for range 10, it's going to tell me, okay, I'm ready to give you that range. But it didn't give me the range. So this is another example, not of a generator because it's its own thing, but of lazy evaluation. It doesn't create the numbers until we ask it to. Once we say, hey, make the numbers, then it makes the numbers. Or once we force it to make the numbers because we stuck that range inside a comprehension, then and only then does it evaluate. So that's lazy evaluation. And this is also an introduction to generator comprehensions or generators. Um, okay, um, so let's see what happens if I want the length of a generator. Uh, right? I mean, we were able to take the sum. Sum is a nice function. I put this in sum. Suppose I want length instead. Let's try that. So I'm going to stick this thing inside my length. And what's going to happen here? Let's see. I got an error that a generator has no length. Now this makes perfect sense because length tells me how many objects are in a collection, how many things are in a collection. And I'm not storing these things all at once. This is just an agreement that I'm going to make these things when you need them. So this agreement doesn't have a length. So, and very clearly it says, hey, this is the wrong type of thing. It's not a set, it's a list. That would be a right type of thing. This is the wrong type of thing. This object is of type generator. And because it is type generator, it has no length. So very clear error message, and you should understand why it gives that error, because it's not storing all these in memory at the same time, so it can't tell you how big the collection is because it never makes the collection. It just creates them one at a time as needed. Okay, so let's go back to sum, see that sum still works. You might be wondering, okay, but don't these generators have their own parentheses around them? And the answer is yes. But Python knows that if you remove the parentheses, it knows what you mean by that. So it'll automatically default to assuming you want a generator or a generator comprehension here. What if you added an extra parentheses? Oh my gosh, so many parentheses. Well, then it's just an order of operations thing, right? We're taking the sum of this thing and the parentheses tell us what to focus on. And then inside those parentheses, it found the generator comprehension, which it then acted on, and it gave us the right answer as well. So that is an introduction to generator comprehensions and the idea of lazy evaluation.